Right, greetings all, hope this finds you well as always. It's now time for the latest update from the machine shop, where we're up to and what we're on with. And one of the things we've been on with this week isn't actually machining at all. It's actually a bit of machine tool repair, and it's on the Harrison lathe. We had an issue with this machine a while ago. It's that one of the heavily used lathes in the shop, it probably does the vast majority of the work. And the problem we had with it was that when you were screw cutting on it, periodically the feed hand wheel here would jam absolutely solid. Although you're not actually using that hand wheel when you're screw cutting, because the saddle is actually being pulled along by the actions of the half nuts on the lead screw. Due to slack and wear in that mechanism of the hand wheel, it was jamming up absolutely solid. So last week, Brian set to, under my sort of vague direction of, you go and take that to pieces, I'll go and see if we've got a manual for it. And by the time, in the 10 minutes it took me to find the manual, he'd got it in pieces and was well on with getting the apron off. Now, what we found was that, first of all, there's two components to think about. First of all, there's the rack here. You'll see it on the underside of the bed. Has a pinion here, which engages with it, and it's that pinion rotating that what moves the saddle up and down the bed. Now, first of all, this is the old pinion, and you can see there's quite a lot of wear on those teeth. This pinion also runs in a bronze bush in the back wall of the saddle, and as you can see, there's quite a lot of wear on that as well, so that was also replaced. And then when we took this lump off, it's called the saddle on a lathe. It's basically where all the operating mechanisms live. There was also some minor damage to some of the other gearing in there. So that was actually hand fettled after the machine had been reassembled. What I basically ended up doing was moving the saddle backwards and forwards, working out where the tight spots were, and then very carefully looking at the gears. And 90% of the time you can spot the damage. It's usually a mashed tooth or whatever. And so then very carefully with a needle file, removing that damage, and then try, repeat, until eventually we got it running lovely and smooth. Much smoother than it's ever run all the time I've used it. So another excellent job that Brian's a smashing job of there. I was considering he'd never taken a lathe like this to pieces in his life before. It was very funny. I said to him, can you make a start on stripping this down, please? Yes, certainly, he says. And he asked the quite reasonable question, have we got a manual? I said, yeah, I'll go and find it. It took me 10 minutes to go and find the manual, and in the time I'd found the manual, he'd actually got the machine well on the way into pieces, and was well on with getting the apron off and finding out what was actually wrong with it. So full credit to the man, he did a smashing job. So that machine's now fully back up and running. And tomorrow, the job that's going through it, hopefully, is its first screw cutting job in a while, which is screw cutting these Black 5 bogie spring hanger bolts, which were roughed out by Craig a while ago. At the time, we couldn't screw cut them because the machine was US. But now the machine's back up and running, so they can be screw cut tomorrow, along with their matching nut blanks, which are there they are, along with the matching nut blanks. So that's the first job that's going to go through it tomorrow, to hopefully prove that it's all been rectified and sorted. Right, in other jobs, we have the, well, I don't want to describe them really, connecting rods, for want of a better word, off the crane. These are the connecting rods. The crane's quite simple, well, relatively simple from an engine point of view. It has two steam engines, effectively, mounted onto the crab sides of the body, and then these in turn drive a crankshaft, off which power for all the various winch drums and functions and whatnot have been taken. Now, one of the jobs I wanted to do was to get the rods and reassemble them with the re-metal brasses and the little end pins and all the rest of it. But I wanted to do it on the bench, so we could actually, if there were any problems, which there were a couple of, there were some damaged threads on some of the bolts, and one of the pins was a bit tight because the hole in the rod was marred. But I wanted just to find out where those problems were before we were dancing around on the side of the crane trying to sort them. So they've been dry reassembled, and they're now ready to go back onto it, so I'm happy with them. They are good to go. In other news, these rod brasses off 76079, we saw these in progress last week. Well, they're now ready for white metaling. Now, you will notice there's a pen notation on the front of them. That's to tell whoever casts them what size core to use. The core I talked about last week, it's the idea of putting a mould into the middle of it, so you're not wasting white metal, using it unnecessarily. So the trick with the core is to get big enough so that if it's not quite on centre, you've got enough white metal to bore it back to true and on size, but not so big that you're unnecessarily wasting white metal. And so, to be honest, those are guesses based on experience. I usually state a core in roughly quarter-inch increments, and whoever casts it knows that that's the largest size I'm happy with being used. So they'll see what they've got that's sort of the nearest to that, ideally slightly undersized if it isn't an exact match, and then those can be cast. So they're all ready to rock and roll. Now, one thing I have done is these are not turned to finished sizes. The reason I haven't turned the finished sizes, I can't remember if I mentioned this last week, is that when that white metal is poured into that casting will distort slightly. It's mainly casting stresses being relieved, effectively it's being heat treated, and so that casting will go slightly, maybe 10, maybe 20 thou out of round. Now, if I turn that to finished size, there will be a problem because it suddenly wouldn't fit in the hole anymore, and because it's on finished size, I don't have enough meat on it to turn it back to round. So these are deliberately left a 1/8 of an inch oversize on the outside diameter, so that once they've been white metalled, they will then go back into the machine and be finished machine to size. Interestingly, if we remetal these bushes, they tend not to move a second time. So my suspicion is it's purely the release of casting stresses in the body, in the casting here, and once those have been released, well, they don't do it again. So the lads will get the white metal cast into those. To do that, they first of all tin it with solder, then they put the core in, seal around it with fire clay, and then they pour molten white metal into the gap between the cat bush and the core. And as I said last week, these serrations are machined into the inside to give something for the white metal to mechanically key to. Right, now, last week somebody asked, what sort of fit do you aim for with these bushes? And the idea is, it's this mythical thousandth of an inch per inch diameter. So that means running fit, thousandth of an inch oversized for every inch diameter. The press fit, thousandth of an inch per inch diameter. Now, the trick is to get those fit after the bush has been pressed. It's all very well machining a bush that's, it's perfectly on size, and then you press it in and it's too tight suddenly because you haven't worked it out right. So how do I actually work that out so it all works? And I've tried to outline the maths roughly here. Now, a little habit I have when I'm working these measurements is I talk about A numbers and F numbers. The A is the actual number, the actual physical measurement taken off the locomotive, and the F is the fit. And I often, as you can see, I tend to underline one of them and draw a square around the other, purely so that when I'm looking at a sheet of paper to quickly check, what dimension is it, I make sure I get the right dimension, okay? So the first two numbers we have the outside diameter of the bush and the internal diameter of the bush. These are taken, the outside diameter is the diameter of the hole in the rod into which the bush will be pressed. The internal diameter is the diameter of the crank pin on which the bush will fit. And for anyone who's wondering, this is for the right-hand leading bush of 76079. Okay, so we have 6.521 for the outside and 5.219 for the inside. Okay, now the first thing we need to do is work out a fit, and we'll do the outside first because that's the easiest. Very simple. As I said, our fit for a press is a thousandth of an inch per inch diameter. So I will call that 6 inches diameter. So that's plus 6 thou. So that takes us to 6.527 for the fit for the outside diameter. Okay, right, now the internal, and this is where we have to take something else into account. That's what I call the squash allowance. When that bush is pressed in, it will shrink roughly half the press fit. I emphasise the word roughly. This isn't a hard and fast predictable thing. It depends on so many different factors. The wall thickness of the bush, the material around the hole is, whether it's tapered, yada, yada, yada. But for purposes of calculation, it compresses roughly half the press allowance, okay? So that's the first thing I've got to take in. Now, I call it a squash allowance, but that's purely just my own records. So for the internal diameter, we have to add on 2 numbers this time. The first is a 3 thou for the squash allowance. The second is 6 thou, which is to give us a running fit on the crank pin. So that's actually 9 thou oversized, which gives us 5.288. So those are the 2 numbers now that we machine the bush to. The bush will be machined to those numbers. Then once it's pressed, that lower number will shrink roughly 3 thou. After it's pressed, that bush will shrink 3 thou, and so that number will come down to somewhere around 5.225-ish. It may be 224, it may be 226, but it will be somewhere around there. And at that point, that will put the running fit within a thou of where I want it, okay? And so then that should then run and work and do the job. And so that is how we work out the numbers for pressing bushes, okay? Because somebody asked last week, and I thought, I'll explain that. So anyway, that system works. It's worked. I've done a lot of these over the years, and it's worked for every last one of them. So anyway, folks, that's where we're up to. Now, I'm not going to be here at the tail end of next week, and there's this Christmas thing coming. So this will probably be the last video from the machine shop until the new year. So I'd like to take this opportunity to wish all and sundry a very Merry Christmas on behalf of the team here, from myself, Craig, Brian, and all the rest of us. I wish you all a very Merry Christmas and a very Happy New Year. Take care, and I'll see you around.